Video we're going to talk about the skill of multiplying 2 and 3 digits by a 1-digit number using both the standard algorithm but also the area model. First off, reminder that multiplication is just doing repeated addition more efficiently. So 42 times 5 is really just showing 42 plus 42 5 times, but 42 times 5 when we multiply is just a more efficient way to solve. We are going to talk about how to solve 42 times 5 and other problems that are multiplying 3 or 2 digits by a 1-digit number, both using the area model and the standard algorithm way. When we're doing the area model, we draw out a rectangle and then we separate it based off of that 2 or 3 digit number. We're actually going to turn 42 into expanded form. So that's why 40 is above one section of the box and then 2 is above the other section of the box. Then we put the second digit that we're multiplying by off to the side. What we're doing here is we're using each box almost as if we're solving for area, length times width. So for my very first box, I'll highlight that here. We're going to use the side lengths that we're given, which are 40 and 5. Using the pattern that we've covered previously, I can do 40 times 5 pretty quickly. I spot 4 times 5, which is 20, and then I can just add my 0 on. In the next box, which I will highlight here in blue, we have a new length and width. This time we're only focused on the 2 in 42. So this time I'm doing 2 times 5, which gets me to 10. From here, I just need to add up the areas of each box to get my final answer of 210. So 42 times 5 is 210. The standard algorithm is when we need to stack our numbers lining up our place values. We're going to multiply that 5 by all of the top numbers. So first we're going to work straight up and do 5 times 2. 5 times 2 is 10, but I can't put 10 in one place value. So similar to how we do addition, we're going to carry our 1 to the next place value and drop down the 0 from the 10. We've now multiplied 5 times 2, so we're going to shift our way over, work our way over left. Now we're going to do 5 times 4. 5 times 4 is 20, but we add on any of the extra numbers that we're carrying over. So in this case, we're actually doing 5 times 4 plus 1. Again, 5 times 4 is 20, but when I add on this 1 that I carried over, I get 21. This time, I can just drop my 21 down because there's nowhere for me to carry a 2 over 2. So I can just drop it down, getting the answer of, again, 210. Two different ways to solve, both get the same answer. Now let's look at a 3-digit number times a 1-digit number. This time I have 257 times 8, so I'm going to expand 257 above my area model. So I have 200 plus 50 plus 7 multiplied by 8. So again, I'm going to use my pattern. 200 is a multiple of 100, so I can quickly multiply 8 times 2 to get 16, and then just add on my 2 zeros. For this next box, I'm only going to focus on the 50 times 8, which is 5 times 8 is 40, add on my 0, and then my last box I'm going to focus on 7 and 8, and I get 56. From here, I can add up all 3 of those areas to get a final answer of 2056. Let's set this up in standard algorithm. 257, my longer digit goes on top, multiplied by that 1 digit. And this time I'm going to be multiplying my 8 by all of the top numbers starting in the ones place. 8 times 7 is 56, so similar to addition, I'm going to carry over that 5, drop down that 6. Now I'm going to do 8 times 5 plus 5, so starting with 8 times 5 is 40, plus 5 is 45, so I'm going to carry my 4, drop down my 5, 8 times 2 is 16, plus 4 is 20. And I can just drop that one down because I have nowhere else to carry it to. So again, my final answer is the same at 2,056. Last one, this time I have to set it up completely. So starting from nothing, I'm going to start with my large rectangle, and then I'm going to break this into however many chunks my first digit has. So in this case, I have 392, which is 3 digits. So I have my 300, my 90, and my 2. Expanded out 392. Multiplying times 7. When I do my area, my 300 times 7 to get 2,100. When I do my area of this next one, 90 times 7, 630. And then I multiply 2 times 7 to get 14. I can now just add up all of these areas to get my final answer of 2,744. We should get the same answer as we set up our standard algorithm. I'm going to multiply that 7 times all of the top numbers starting in the ones place. 7 times 2 is 14, carrying the 1, dropping down the 4. 7 times 9 is 63, plus 1 is 64. So I carry that 6, drop down the 4. 7 times 3 is 21, plus 6 is 27. This one I can just drop down because I have normal digits to carry it to. And again, getting the same answer as my area model. 2 different ways to solve, same correct answer.